Hello, in this video, let's make a sketch of rational function with oblique or slant asymptotes. So when we make a sketch, we usually collect two pieces of information, the intersects and then the asymptotes. So for the intersects, there are two kinds, the x and the y. To get the y-intercept, we make x equals 0. If x is 0, that means we have 0 squared minus 0 minus 2 divided by 0 plus 3, which is negative 2 over 3, which is negative 2/3. So our y-intercept is negative 2/3. To get the x-intercept, we make y equals 0, and that means we are now solving 0 is x to the 2 minus x minus 2 divided by x plus 3. To solve it, we could use cross multiplying. 0 times x plus 3 is 0. 1 times x squared minus x minus 2 is x squared minus x minus 2. At this point, we can either use quadratic formula because we have quadratic equation, or we could use factoring. To factor, we need two numbers that multiply to negative 2 and add to negative 1. Well, that would be negative 2 and positive 1. And since we're multiplying two parentheses and getting 0, that means one of those parentheses is 0. Either x minus 2 is 0, which means x is 2, or x plus 1 is 0, which means x is negative 1. So these are our intersects, the y and the x. The next is the asymptotes. There are three types: the vertical, horizontal, and oblique. Vertical happens when the denominator equals to 0. Our denominator is x plus 3. So if we make x plus 3 equal to 0, that means x is negative 3. So our vertical asymptote is x is negative 3. Horizontal happens if the degree on the top is less than or equal to the degree on the bottom. That's not true, because our degree on the top is bigger. So oblique happens if the top degree is one more than the bottom degree. And that's exactly our situation, because our top degree is 2 and our bottom degree is 1. The top is one more than the bottom. So we have oblique asymptote. To find the oblique asymptote, we do lone division. So we actually take our polynomials just the way they were here, and we do the division. So here is the division: x squared minus x minus 2 divided by x plus 3. To get from x to the 2, we need to multiply by x. And then multiplying through, x times x is x squared, x times 3 is 3x, changing all the signs, and adding x to the 2 cancels, minus x minus 3x is negative 4x, carrying negative 2, excuse me. What times x makes negative 4x? Well, that's negative 4. Multiplying by negative 4, we get negative 4x, minus 12, changing all the signs, we get remainder of 10. Now the remainder doesn't matter when we're looking for the asymptote. What matters is the top, the whole part. This is our oblique asymptote. Now we have all of the components and we can make a sketch. So let's zoom in and put the grid so we can make a sketch. So here is our coordinate axes. Let's redo that. The y-axis, the x-axis. So we have the vertical asymptote at negative 3. So that means negative 1, negative 2, negative 3. So there is imaginary vertical line that our graph will not cross, and it's labeled x is negative 3. Then we have oblique asymptote that runs through x minus 4. Well, if y is x minus 4, that's a straight line with a y-intercept of negative 4, so we count minus 1, minus 2, minus 3, minus 4. And then from that point we have rise over run, 1, rise up, run to the 1, rise 1, run 1. So 1 unit up, 1 unit over. If we connect these dots, we will get the slant asymptote. So this is our oblique line. Then we have our intersects. We have the y-intersect at negative 2/3. That's negative 1. Negative 2/3 is about here. Then we have the x-intersects, negative 1 and the positive 2. So here they are. Now we connect the dots. And if we connect the dots, we get this piece. So we have to approach our asymptotes and go through all the dots that we have collected. And that's the sketch. Now, there is also a second piece. So here, let's look at our calculator and see if that's what we are getting. So y, and the whole thing needs to be in parentheses because we're trying to divide all of the x squared minus x minus 2. We're dividing by both x and the 3. So we have to have both top and bottom in parentheses. And then here is the sketch. And it looks close to what we have. But there is another piece that is below that we're not seeing. Now that piece is going to go like this. And it'll get close to our asymptotes. And we're not seeing it on our calculator because our calculator goes from negative 10 to 10, negative 10 to 10. And this part is below negative 10. So we're not actually seeing it on the calculator. We can't see it if we change the window. So if we go to the window and we add more to the y, let's make y a little bit more up. So let's go to 20 and then minimum is negative 20 and the maximum is positive 20. Let's count by 2's. So here is the different version of the same graph. And we can see that if we haven't adjusted the window, we would have missed the bottom piece. And that's on the test, that's very important because just this part is not a complete picture. We also see that this graph has a very strange tilt. It's approaching our oblique asymptote. We can see that it does if we type in our oblique asymptote as a second equation. That was x minus 4. So if we put that in, here is our oblique asymptote, and we can see how our graph gets really close to it. And that's a sketch of a graph with oblique asymptote. And that's all for this video. Thanks for your time. Take care.